now that you've enjoyed doing the direct comparison test, we're going to do the limit comparison test. At the end of this lesson, you'll be able to determine whether an infinite series converges or diverges using the limit comparison test. Alrighty, we're still going to be just like we did in the direct comparison test. We will be taking our series in question and we'll be trying to compare it to another series. In this case, we don't care which one is bigger or smaller, so that's one thing that's going to be a little bit easier about the limit comparison test. We mostly will just be trying to find a function that's a little simpler to deal with than the one that they give us. And I'm just going to look at here what we will do once we have both series, or both the a sub n and b sub n. What we are going to do is divide them, and we'll find the limit as of n approaches infinity if you were to divide the two. And if we get a number that's bigger than 0, then some number, and it's not infinity, it's finite, then we will find out that both of those functions will either converge or they will both diverge. If we get an answer of 0 for our limit, and the one that we picked to compare it with converges, then the one in question also converges. And if we find the limit is equal to infinity and the one we picked diverges, then the one in question also diverges. So again, this is just going to take lots of picking a function, and you'll find ones that do work and don't work, and it's just going to take a lot of practice and trying something that doesn't work, so then you try something else. So here we go. Does the series from n equal 1 to infinity of n plus 2 over n squared plus 4, does it converge or diverge? Use the limit comparison test. Now keep in mind, you don't necessarily wouldn't have to use a limit comparison test in this one, because I might be able to use the integral test or the nth term test or something like that, but specifically we are going to practice the limit comparison test on this one. So in this specific example, our a sub n will equal n plus 2 over n squared plus 4. What we need to do is pick a b sub n. All right, so how do you pick a b sub n? Sometimes what I like to do is, if I didn't have the 2 and the 4 there, I would have n squared over n, which reduces to 1 over n. So that's something a little simpler. I want to try to pick something somewhat simpler, but somewhat the same as the one that's already there. So those are somewhat similar, I suppose. All right, so now what I would like to do, the next thing that I'm going to do, actually before I compare those two, let's find out what's going on with b sub n. So if I found out 1 to infinity of 1 over n, I would find out on this one, actually this is really nice because this is a p series, so if we can pick a p series for the one to compare it to, more power to you. All right, so this is a p series. Our p would actually equal 1 in this case because the power would be 1, and since the p is less than or equal to 1, my series is going to, this series right here is going to diverge. So now we're going to compare these two to see if that helps me. So we're going to have the limit as n approaches infinity of a sub n over b sub n, which will end up being n plus 2 over n squared plus 4 all over 1 over n. And then I am going to, on this one, multiply by the reciprocal. So I'm going to get n squared plus 2n over n squared plus 4. And now if I find the limit as n approaches infinity, I will get infinity over infinity, which is going to allow me to use L'Hopital's. And if I use L'Hopital's, I will get the limit as n approaches infinity of 2n plus 2 over 2n. And still I will get infinity over infinity, so let's use L'Hopital's one more time. And if I do that, I'll get 2 over 2, which is equal to 1. So then I look at those rules that we had on the previous slide, and I notice that I got some number that's bigger than 0. So it says if the limit as n approaches infinity of a sub n over b sub n equals some number bigger than 0, then they either both converge or they both diverge. I really like it when it comes up to be that one. So since this one, the one that we compared it to, diverged, then a sub n will also converge. So we can say, since the limit as n approaches infinity of a sub n over b sub n was equal to 1, or some number bigger than 0, and the series, our b sub n series, diverges, then equals 1 to infinity of a sub n also diverges. So there we have it. All right, example 4. Does the series n equal 2 to infinity of 1 over ln n squared converge or diverge? Again, we're going to use the limit comparison test. So our a sub n will equal 1 over ln of n squared. And then we just need to decide what our b of n is going to be. And I really don't want to pick ln again because I think trying to take the integral of that or trying to find whether it converges or diverges is going to be difficult. So I would like to stick with an n. Let me choose 1 over n, and then I think either in class or maybe at the end of this video I'll show you why I might not want to pick 1 over n squared to do this. So I'll just pick 1 over n again because that's just a nice one. We found in the previous example that when we found this diverged. It was a p-series. So we're going to stick with that and see if that works. So here we go. We're going to find the limit as n approaches infinity of a sub n over b sub n, and I'm going to multiply by the reciprocal, so I'll get n over ln n squared, and then if I try to approach infinity, I will get infinity over infinity, so that allows me to use L'Hopital's rule. So this is the limit as n approaches infinity. The derivative of n is 1. The derivative of the ln squared, please remember that we'd have to make this u squared. So the derivative would be 2u times the derivative of ln, which would be 1 over n. So this actually is going to be 2u, which is ln n over n. So that's my derivative. So this is 2 ln n over n. So I'm going to multiply by the reciprocal again. So I'll get n over 2 ln n. If I approach infinity, I'll still get infinity over infinity. So time for L'Hopital's one more time. So I'll get the limit as n approaches infinity. The derivative of n is 1. The derivative of 2 ln n is 2 over n. And then if I multiply by the reciprocal, I'll end up getting n over 2. And this time when I plug in infinity, I get infinity. So we'll go to our rules. I found out that the limit is equal to infinity. That it was the rule C. It said if b sub n diverges, then a sub n also diverges. So we got lucky on that one, that this one also diverged. So we can now say, since the limit as n approaches infinity of a sub n over b sub n equal to infinity, and as I started at 2 to infinity of b sub n, since I found out that that diverges, then I can say n equals 2 to infinity of 1 over, we'll just call it a sub n. A sub n also diverges. So hopefully now you can use the limit comparison test to find whether an infinite series converges or diverges.